What a kind and generous introduction. Thank you so much. I appreciate it. I am so excited to be here this afternoon for leveraging brains and beauty for effective data storytelling. Please feel free to connect with me on LinkedIn, and hopefully that will be something that from which you'll gain additional information. I have a couple of books that I have written. One of them was ranked as a #1 new release called Mentoring Mastery. If you're interested, there's a QR code. And also Unleashing Firepower. I'm a co-author on that particular book. My chapter is on the firepower of data. One of my favorite topics, and it will be released day after tomorrow. It was given as a prize, as a matter of fact, in my workshop this morning on avoiding death by PowerPoint, and perhaps, I hope, I shall not, subject you to the very same death by PowerPoint this afternoon. So perhaps this will be good for you. And I also have candy that I'm giving out for those of you who are able to answer questions correctly. So, yeah, I will hide that down here so it won't tempt you. So let's go ahead and get started. Excuse me. Labadiana, ponios irponai, achu kada teoje, jaugiosi, kalieramas ved kavieti irtikiosi, kadiums patix manopristatimas. Yeah, thank you. Well, you're very kind. What I tried to say, I hope I didn't mess it up. Good afternoon, ladies and gentlemen. Thank you for coming. I'm happy to be speaking again, and I hope you like my presentation. So let's get started and build stuff. Beginning in March of 2014, West Africa faced an unprecedented menace, the Ebola virus outbreak. This catastrophic event would claim 11,000 lives and touch the hearts of millions. But in the face of this daunting adversary, the power of actionable data and innovation emerged as an unsung hero. Picture a world where timely, precise data became a lifeline. Information itself became a big beacon of hope. The hero of our story, the real hero, is Dr. Masoka Falah. He was a Harvard-trained epidemiologist who returned to Liberia, his homeland, to confront the outbreak. Now, with a profound understanding of data and underlying status, he pioneered something for contact tracing, training local volunteers in the process. Local technology became their aid, and his respect for tradition and respect of central resources earned the trust of the local community. This innovation significantly reduced Ebola transmission rates in Liberia, and it was hailed as a best practice by the World Health Organization. Dr. Falah's dedication also played a vital role in developing a rapid diagnostic test, offering results in only minutes rather than days. His story illustrates how data, technology, compassion, and cultural sensitivity can be combined to save lives and halt an epidemic. But this story isn't just about the past. It's also about the future. It's about leveraging data and technology to prepare and respond to health crises and other crises that may lie ahead. All of these factors exponentially increase the value of actionable data during the West African Ebola crisis to give those medical professionals and scientists the insight they needed to make those tough decisions, answer the incessant questions, and ultimately meet the challenges before them. And well, actually, they exceeded those challenges. Speaking of which, Techopedia defines actionable insight as information that can be acted upon or information that gives enough insight into the future that the actions that should be taken become clear for decision makers. In other words, meaningful data that's useful for making a decision, answering a question, or solving a problem. And remember those 3 tenets of actionable data, because I guarantee you will see them again. It distinguishes data that can improve things from data that serves as nothing more than fancy window dressing or interesting trivia. But in data storytelling, with every data visualization, you have to start somewhere. Okay, you have a concept or an idea in mind. And then you have as your end goal a completed visualization consisting of one or more graphs. Now, how do you get from concept to reality? I would like to think of this data storytelling journey we're going on as a spectrum, along which I suggest various stages, specifically 5, for best practices in getting from the idea on the left to the completed visualization on the right. These 5 stages are conception, inception, perception, inspection, and direction. Now, the way I've listed these stages from left to right across the screen here, you might assume that I intend for them to occur one after the other. Okay, maybe so, but they can also be concurrent and even overlap. In any case, we need to look at these in the light of a strategy that's comprehensive and with a positive mindset. For you see, this is supposed to be an enjoyable thing for us as developers to do, not a drudgery. And don't forget, before your concept becomes a reality, it needs to be visualized and it must stand up to scrutiny. I'll give you more detail on that in just a few minutes. Well, let's jump into this thing. First stage, conception. You have to start the race somewhere, don't you, right? Well, how exactly does that happen? Well, I see the key word here as articulate. Now, if you're taking notes using the handouts that were provided on the seats scattered throughout, you will notice that each of the stages has a name, an imperative, and a key word. So, for the first stage, the name is conception, the imperative is start the race, and the key word is articulate. And you will notice that as you follow along on the sheet, if you'd like, those are blanks. If you want to fill them in, they correspond to the words that are underlined on the screen. Hopefully this will help you for future reference. So, as you articulate the need, it's important to understand your audience. I talked about that this morning. You know, those are the people that are going to be consuming your data. You have got to know your audience. Look, you wouldn't articulate the need to a room full of project managers in the same way that you would to, say, a group of business intelligence specialists, or to DBAs and programmers in the same way you would to, say, a bunch of university faculty members, other developers, or anybody else. You know, speak to each group at their own level using terms that they can understand. It's equally important for you to know your data. I mean, that's a given, right? You need to be able to articulate what you want to do with that data, and doing so is where your concept or idea is conceived. Now, the most important thing to be articulated is the purpose for your data. That is, what are you trying to show? Are you showing comparison, distribution, composition, or relationship? Well, the answer to that is going to determine the type of visualization that is the most appropriate for the story that you are telling with your data. That, in turn, is going to lead to even more questions that will guide you to refine your approach along the way. I want you to think of this as like a hierarchy. Dr. Andrew Ebola, chairman of the Department of Business and Economics at the Catholic University of America in Washington, D.C., has come up with an amazing graphics tool that I believe masterfully articulates the need and sets the pace with these 4 categories that he has come up with for data visualizations. All right, let me show you a closer look at Abela's chart chooser cheat sheet. You can see the 4 categories radiating out from the center and the questions coming off of that and the sub-questions and the correct graph type at the very end. So we're gonna make like composition is our example. And you start asking questions. Does it change over time or is it static over time? If it changes over time, what are you talking about, many time periods involved or few time periods? Then if there are many time periods, well then are the differences relative, or are they relative and absolute? So you see, as you ask certain questions, they're gonna lead to other questions as you proceed along the different branches of the decision tree, and that hopefully will lead you to refine your approach and come up with the right graph type. Well, at least the ones that are considered to be the best practice. That's the first stage, conception. Second stage is inception. That is, once the race has been started, right here is where we need to make the case. The key word is advocate. Make the case for expressing the concept visually. Folks, this is very powerful for a couple of reasons, according to Mike Parkinson, founder of Billion Dollar Graphics. He says we're affected by graphics in two ways, cognitively and emotionally. First of all, cognitively. Graphics speed up the way we communicate and help us to better understand and more clearly remember what we've learned. They're like visual clues that we can use to unlock a deeper meaning and focus our attention, so it's more likely that we'll remember what we've seen. Secondly, we're also affected emotionally. Graphics also improve our mindset and affect our feelings. They connect with our creativity by stimulating different parts of the brain, leading us to more fully understand what's being presented. You know, a picture's worth 1,000 words, isn't it? And this is something that no spreadsheet nor tabular report could possibly do anywhere nearly as quickly. So think about it. Do you realize what Parkinson's saying here? We are affected both cognitively and emotionally. In other words, graphics get a hold of both our brains and our hearts. What better marriage could you possibly want other than mine? Anytime that you're able to touch both the brain and the heart, man, oh man, you've got something good going. You know what? That's both beauty and brains at work. British data journalist David McCandless said in a 2010 TED Talk that sight by far has the highest bandwidth of any of the five senses. You know, about 80% of the information we take in is by eye, he said. You know what? Additional research in the years since he said this has shown that to be more like 90%. To that point, a couple of European research professors, Emery Sawyer and Robin Hogarth, teamed up on a study in which 3 groups of economists were asked the same question regarding a particular data set. The results of this study seemed to support McCandless's TED Talk claim. One group was given the data and standard statistical analysis of the data. Now remember, they only had one job to do, just one question to answer, and in spite of all that, 72% of those economists could not get the answer right. A second group was given the data, statistical analysis, and a graph. Now, how many of y'all think that the second group did better than the first group? Show of hands, real quick. What do you think? All right. Well, you're right. I can't see your hands, but yeah, you're right. They did do better, but not by much. Still, 61% of that second group couldn't pull it off. Again, they only had one question to answer. A third group was given only the graph, right? Nothing else. No data, no analysis, nothing but the graph, and only 3% of them got the answer wrong. You know what? This certainly makes the case for visual representation of data, and it absolutely is something that I believe we can advocate. That's the stage of Inception. Well, guess what? I'd like to have a quick review and see if any of you can win some candy. I got some right here. Who can tell me what is the first of the, if I can open this bag, here we go. Who can tell me what's the first stage? Starts with C. Conception, right, I heard over here, and forgive me, I can't see a thing with these lights. So this may not be a good idea. I might hit some, I hope I don't hit anybody in the head. All right, first stage is conception, that's correct. What's the second stage? Starts with an I. Inception, very good, sir. Good catch, in spite of all I see is, the only thing I see is spots, I'll be honest with you. Right, conception, inception. All right, we have key words for each of these. Can y'all tell me what the first key word is? Articulate, right, it's on the screen, right. Who can tell me what the second key word is? Advocate, it was somewhere in this, I can't even see you, sir. Let me try that again. All right, maybe arc it a little bit, hand it to whoever it was that said that. Right, keywords, articulate, and advocate, very good. All right, put this down here and start it up again. So, you've learned to start the race, and you've made your case. Now, let's motivate the base. Keyword here is educate. The third stage is called perception. Folks, we're not going to get very far in this data storytelling journey if either the target audience or the stakeholders are not on board. You know what? It's up to you and me to educate them, making them realize that they've got some skin in this game. I mean, they can't take ownership or provide the necessary backing, financially or otherwise, if they don't understand what you're trying to present, or if they can't see what's in it for them, Or if the data visualization does not help them to make a decision, answer a question, or solve a problem. See? I told you that you would see those 3 tenets of actionable data again, and you'll see them even more. How do I do this? By understanding some basic principles. You know, folks, that's foundational to any educational initiative, right? So it begs the question, does form follow function? I'd have to say yes. You know, it's the age-old argument, is it not? Is it pretty or is it right? Does it look good or does it work? Now, with this business about form following function, it'll lead to another question, that is, what do we mean by form and function? Okay, function is what you do with the data, that's the brains, whereas form is how to express functional outcomes in the best possible way. Guess what? That's the beauty. Here's some best practices or cardinal rules that we need to keep to ensure that function gets the right priority over form in our data storytelling at all times. Yeah, it ought to look pretty, but it's more important that it be right. I want to show you some examples of what not to do and how to avoid doing it again. First of all, pie charts. Oh boy, you gotta love them or hate them, right? There's typically no middle ground with these guys. I mean, some people think they're the best thing since sliced bread, while others say they're the spawn of the devil himself. Regardless of how you might personally feel about pie chart, suppose your mother baked you a pie when you were a small child and said you could have it all. Maybe not all of it at one time, so she cuts it into 4 slices. Now, how many of those 4 slices, a little bit of subliminal here, would you have to eat in order to consume the whole pie? What do y'all think? 4, yeah, right. Yeah, very good. I'm glad you said 4, yeah. I'm not trying to insult anybody's intelligence. I'm just trying to make a point here. Should be pretty easy to understand that pie charts are supposed to show the parts of a whole. Everybody ought to know that. You'd think. Some people just don't get it. I'll show you what I mean. Take a look at the pie chart in this fuzzy screenshot from the American television newscast a number of years ago. I see a couple of problems with this chart right off the bat. First of all, look at the numbers, if you will. Add them up. You know what you get? 193. How can you have 193% of a single pie? Yeah, it's almost like 2 pies, isn't it? Secondly, check out the sizes of each slice. Okay, 70 is supposed to be bigger than 60, isn't it? Yeah. Well, then how come that 60 slice looks bigger than the 70 slice? 63 also. In reality, the survey questions used to put this news report together allowed for multiple choices. That is, respondents were able to indicate support for more than one candidate. Bingo. Now, that's no excuse for the disproportional slices here. At least now you can see why the numbers do add up to more than 100. In and of itself, okay, that's not necessarily a major problem. But the problem here is that's not the way you show things in a pie chart. We can therefore pretty safely conclude that this pie chart is definitely misleading. And in this particular case, you know what? I think maybe a bar graph would reflect the data more accurately, don't you think? Yeah. Maybe something like this. Look at there, same data, but it's presented in a way that is not misleading. All right, what about line graphs and bar charts? Well, another best practice is that the y-axis should have a consistent scale. Look at this sample bar chart showing the average amount of money paid by consumers in a year on their automobile insurance and how that expenditure has changed over time. Now, upon first glance, you might assume that there's a huge spike between 2015 and 2017. My laser pointer not working, but that's all right. But look more closely at the odd way in which the vertical axis is scaled. Who will be the first to tell me what you see? And I got a reward for you if you can see it. It doesn't start at 0. I think it's you, sir, or somebody in this general direction. Yes, you have stereoscopic voice. All right, that's good. All right, very good. Yes, the axis is scaled from 750 to 1,050 US dollars, thus making the change between or among those years appear to be fairly drastic. You know, the line's going very steep. I'm gonna have to call this chart at least a little bit misleading. By contrast, look at the bar chart on the right. You see, it's the same data, but Who can tell me what the difference is with the second chart? You see it? That's right. It does start at 0. Very good. And forgive me, again, I can't see a thing. I love the bright lights. They make for good videos. They make for bad throwing. Okay. All right. Excellent. Put this down here. Okay. It's scaled to start from 0. There you go. That's what the y-axis is showing. And you can see perhaps a more realistic depiction of the auto insurance spending trend over that same 10-year period of time. I'm going to call this second chart not misleading. Now, let me explain something real quick. Did you notice I didn't call that second chart corrected or whatever? There's a reason for that. Many, organizations, people, institutions, companies, whatever you want to call them, they display their graphics. They represent their graphics however they want. They're going to do it any way they do want without any notice of statistical accuracy. The only thing they care is about making it look good. I don't care what the data says. I want it to say what the boss wants it to say. Yeah. In fact, specific misrepresentation of data occurs in many cases for self-serving purposes. They're manipulating the data, making it say what they want it to say instead of allowing the data to speak for itself. Let me tell you something. I think that we as developers ought to hold ourselves to a much higher standard of accuracy and integrity here, folks, all right? Now, with that being said, I'm not necessarily implying that the y-axis should always be forced to start at 0 and every single case, every single time. Sometimes when you're comparing multiple data sets with multiple series, a bunch of numbers are kind of clustered pretty doggone close together. Let's face it, the only way you can see the difference is to zoom in on that scale. You can't help that sometimes. What I am suggesting is that whatever you do, be consistent and avoid making changes over time appear to be more drastic than they really are. Well, not only should the y-axis be scaled consistently, it should also be labeled properly. Check out this screenshot from a South American newscast with a graph showing the number of COVID-19 tests performed per million among the populations of the 6 countries being depicted. They did that a lot during the pandemic. Okay, so who can tell me what is missing from this chart? Let's try over here. What's missing from the chart? I beg your pardon? Oh, yes, the axis, that's right. Forgive me, it's somebody in that general vicinity. All right, good. That's right. The x-axis, well, technically the x-axis is there, but it doesn't have a label anyway. I know what you mean. No label on the y-axis either. No axis either, Okay, there's merit in the minimalist approach, right? You don't want to over-label things because you know what you get then? Chart junk. And nobody wants that either. Chart junk, you don't want it. But if your vertical axis, or horizontal for that matter, but if it doesn't have a label at all, your chart can be misleading. And guess what? In this case, it is misleading, and I'll prove it to you. Look closely. Do you see how the 7,000 per million in the US is 21 times bigger than the 330 per million in Argentina, right? However, the bar for the US is only just a little bit taller than the one for Argentina, way out of proportion, see? You see a similar distortion, though not as bad, with the bar for Italy. Now, 14,000 is like, twice the size of 7,000, right, roughly here. Once again, Italy's bar, again, is only just a tiny bit taller than the one for the US. Even if the chart had the axes labeled, the scale is still way disproportionate. Therefore, again, I'm going to call this chart misleading. Okay, the distorted perception that this graph tries to portray, at least subconsciously, is that the differences aren't all that great among these 6 countries, when that is simply not true. Misleading. I'll talk a little bit more about distortions with shapes in just a few minutes. Okay, here's some other best practice that will influence our perception. When you're plotting something chronologically, it should go from left in the past to right, the future, along the horizontal, okay? If you're measuring quantity, plot it along the vertical. right? With the smaller numbers at the bottom and the bigger numbers at the top. You might ask, well, Dr. Joe, come on. Why are you showing this to us? Isn't it pretty obvious? Okay, yeah, it is, but here's my point. I've noticed in recent years a trend that seems to want to reverse this practice, this upside down business with the big numbers in the bottom and the little numbers at the top. I gotta admit, it does look pretty cool, but it's still confusing. And that may be consistent with your use of colors, remembering that there are some universal constants. Red means stop, danger, decline. Green means go, safety, growth, right? Now, these days, I know we're encouraged to adopt maybe a more muted palette with concerns over accessibility and so forth, but the principle's still the same. Spencer-Somzak tells us that contrasting colors differentiate among groups, whereas different shades of the same color can communicate the relative strength or weakness of a value. And then, keep your shaped graphical elements proportional to each other. Master statistician and Yale professor Edward Tufte advocates not exceeding what he calls the lie factor. Essentially, it says that the representation of numbers as physically measured across the surface of a graphical image itself should be directly proportional to the quantities, numbers, whatever that they represent. Now, as a mathematical equation, it's often expressed like this. You take the size of the effect shown in the graphic, then you divide it by the size of the effect shown in the data, and it should never be greater than 1. Some would say it ought to be equal to 1. Yes, indeed. Let me illustrate. Let's suppose you wanted to create a graphic that showed a number of development requests that your team receives month by month over, say, a 1-year period of time. Now, being such an incredibly creative developer that you are, well, you decide that you want the icons that represent your, month by month requests to look like little wrenches. Why not? Okay. Now, let's imagine that for the first month that you're looking at, you receive 10 such requests, so you decide that you're gonna make your wrench look like this little bitty one. It represents 10 requests, 10 JIRA tickets, however in the world you're gonna track these requests, all right? Now, let's say the following month, you receive 30 such requests. If you're going to keep the Tufte's lie factor and not exceed it, whatever, how much bigger should your second wrench representing 30 be than the first wrench representing 10? Shout it out. 3 times, that's right. It should be 3 times bigger. Smart developers you are. Large brains you have, right? So, right. Anyway, your second wrench then should look like this one. Everybody with me? Right, this one's about maybe 3 times bigger than that one and well, not really. Just go with me on it. That's the closest thing I could find. All right, now, suppose that you are angry about those JIRA tickets and you do not ever want to see another JIRA ticket again as long as you live. You cannot stand the fact that you have so many development requests because your entire team has decided to go on vacation to Abu Dhabi or something. You are so mad, you are so angry, you are so infuriated, you decide you are going to make that second wrench look like this. Ladies and gentlemen, you have just exceeded Tufte's lie factor. Get it? All right, baby thrastika. I don't know if I said that right, but I want to show you a real life example. All right. In one of their iterative product releases for a new iPad model several years ago, Apple touted its greater battery capacity over its predecessor. Rightfully so. A 17% increase in battery juice is pretty significant. But look at this graph, though. The battery icon on the right, representing the capacity of the new iPad, I don't know, it looks like maybe 3 or 4 times bigger than the one on the left representing the predecessor. I don't know about you, but that's way, way more than 17%. And as much as I like my iPad, that, my friends, is a misleading graph. Finally, always use the right tool for the right job. Hey, you wouldn't use a chainsaw to carve a turkey, would you? How about a sledgehammer to crack a walnut? Of course not. Don't be silly. Well, the same principle applies with data visualizations. All right, remember Bella's chart chooser. Let's take pie charts, for example. Pie charts are great. Yeah, well, unless you're one of those that think they're the spawn of the devil. But they are great, as long as you use them for the purpose that they're intended to be used, right? Okay? But wait a minute. 2 of them side by side? Yeah, nah, not so much. That doesn't work. Now, to be honest with you, the two pie charts you see on the screen are perfectly accurate. There's nothing misleading or deceptive going on here. However, you need to go back to make the case, the inception stage, and ask yourself a very important question. What in the world are you trying to show with this thing? Can you do any of the three things I talked about, right? The tenets of actionable data. Does it help you to make a decision, answer a question, or solve a problem? Each chart by itself is trying to show how these 5 countries compare among themselves and to what extent they contribute to the whole. The two pie charts together show how that overall makeup changed from one point in time on the left to the second point in time on the right. Just that simple. Now, for the sake of the argument, it really doesn't matter what time frame is being compared in each pie, nor what the slices stand for. But here's the problem. The human eye, together with the human brain, simply does not have the spatial acuity to perceive minute variances across multiple dimensions at the same time. What'd he say? Okay, in simple terms, for those who would use a chainsaw to carve a turkey, it's pretty hard for us to see them differences in these slices when they're side by side like that. Yeah, precisely, that's the point. So, while the pie charts, they are indeed accurate, they are not actionable because you're not able to do any of the 3 tenets. Remember the 3 tenets of actionable data? Who can tell me what they are? Shout them out. What are the 3 tenets of actionable data? Should help you to do 3 things. Who remembers? Solve a problem, ask a question, and make a decision. Boy, you get 2 pieces of candy. All right, very good, sir. And you caught them both. Wow, that is absolutely amazing. Thank you, sir. All right, that's right. Should help you to make a decision, answer a question, or solve a problem, okay? Now, why can't we do it with this chart? Well, because you can't tell just by looking at it. Did you hear what I just said? Isn't that the whole idea behind visualization? The visual part. You can't even spell visualization without spelling visual. Listen to me. If you can't tell just by looking at it, it's not actionable. If somebody has to explain it to you, it's not actionable. If you can't figure out what's going on, it's just plain flat out not actionable. I get worked up about this. All right. Now, what if we were to express the same data as side-by-side bar graphs? Yeah, maybe. Watch what happens. Boom. Well, look at there. You can clearly see the trend that they were trying to show, right? Just like that. The order of the countries from 1 to 5 was completely reversed in that second time period. Easy as pie. Oof. Up to this point, you've started the race, you've made your case, and you've motivated the base. You just got that. Now let's give it some space with the 4th stage of the spectrum by asking a question, does it stand up to scrutiny? This is inspection, with the key word being investigate. Hey folks, being totally transparent is going to help you to avoid the pitfalls of bias and ethical misuse of your data while it's being inspected. And if you've done your due diligence, you are not going to cringe when you get these questions. You know the questions I'm talking about, your favorite questions. Did you assure data quality? Where did you get your data? How do you know it's right? Yeah, you won't be bothered by them. They're not going to intimidate you. Now here's a trend that kind of seems a little counterintuitive. The more complex your data model is, the less likely your people will be to embrace it. Yeah, to that point, suppose you wanted to buy a blender, and the only 2 choices for your grandmother, the only 2 choices are the ones on this slide. Which one do you think would be the better choice for your grandma, right? Beauty or brains? Enough said. Well, having taken transparency into consideration, as you let the data in your visualization project stand up to inspection, it is really important to understand the difference between impact and influence and how that plays into making data actionable. You might ask, hold on, Dr. Joe, I thought impact and influence were the same thing. Well, I do see a difference between them. First, impact is typically recognized as an effect brought on by outside forces that tend to push on your status quo. In a recent Harvard Business Review study, it was found that almost 85% of a company's performance depends upon outside factors. What's funny about it is many of those same companies didn't even have a clue figuring out which of those outside forces were affecting their performance and how. Instead, those who make it a priority to identify these factors are pushed into acting upon them. That is impact. By contrast, influence is typically known to be the power to affect from internal forces that tend to pull on your status quo. You see the difference, right? Impact is external and tends to push. Influence is internal and tends to pull. You know, these are typically factors that your own organization can control. I'm talking about things like the way your data is organized and structured, when and how you're going to stick it into your data warehouse, and then the general outline of your organizational culture and the climate. You know, doing this will pull your strategy in the right direction from the inside. To put it bluntly, as I alluded to at the beginning of this presentation, your idea must be visualized, then scrutinized before it can be realized. You can quote me on that. In other words, if you've given it some space and it can stand up to inspection, you are well on your way to making your concept of reality with actionable data by leveraging brains and beauty. Now, with that said, I believe that we can measure success in this area by capitalizing on this knowledge and turning ideas into reality by blending impact with influence, leveraging them both into a solid game plan to meet short-term needs and provide long-term benefit. Why is that? Well, I'll answer that if you can look at the chart as it builds on the screen. By this time, you will have learned to take your data, differentiate it to come up with information, see the connections to derive knowledge, determine the meaningful connections to connect to grant insight, find the best paths between them for wisdom, and boom. At that point, guess what? You have impact, and you will most certainly generate influence. All right, so what have we learned so far? Well, you've started the race, you've made the case, you've motivated the base, and you've given it some space. Now we come to the fifth and final stage of the spectrum, direction. It's time to put it into place. Keyword here is effectuate. Folks, you are the catalyst, okay? You're the one who has gone through the stages. You're the one who has asked the right questions, done your due diligence, scrubbed your data, chosen the right visualizations, ensured validity and integrity. So what's your implementation plan, right? How do you put it into place? What's the direction here? I see this implementation cycle as a fourfold iterative process. Here's what I suggest. Start off by deploying your solution using whatever organizational protocols and methodologies that you've already got into place, all right? As your stakeholders start using the solutions, they will discover issues. And let me tell you something. Believe you me, they will discover issues. They may call them issues. They may call them defects. They may call them problems. They may do a JIRA ticket. But mark my words, they will discover issues every time. You then analyze those issues and discern the right method to address them. Then you start developing the remediation for those issues, and guess what? The cycle starts all over again. Deploy, discover, discern, and develop. And hopefully you will improve upon your concept each time with each iterative cycle. And I believe this is an effective direction because it leads to progress. In conclusion, you ask, can I really turn my ideas into reality? You certainly can. While developing your solution and moving them along these 5 stages of the spectrum that we talked about, try to ensure best practices are followed. American mathematician John Tukey once said, "The greatest value of a picture is when it forces you to notice what we never expected to see." Let me ask you something. What value do you see in your data? And what ideas do you get when you see it? To stimulate these ideas, graphs and data visualizations are only as good as the data they portray. They should never be any more complex than the data they portray. And above all, they should never paint a distorted picture of the values that they portray. Don't forget Tufte's lie factor. And never let the size of the effect shown in the graphic be greater than the size of the effect shown where? In the data. okay? That's important to remember this. All right. Well, one last review and summary. Here are the 5 stages of the spectrum one last time. What's the first stage? Starts with a C, say it. Conception, start the race. Second stage starts with an I. Inception, make the case, right. Third stage starts with a P. Perception, that's right. Motivate the base. Fourth stage starts with an I. Inspection, that's right. Give it some space. And the 5th stage starts with a D. Direction. Right, direction. Put it into place, that's right. Enterprise account executive and expert data storyteller Spencer Sobczak once said, I love this, data storytelling is both an art and a science. Our data visualizations are the most powerful when they find this balance. You've got the tools, right? So let's go. Balance, art, and science. Let's combine form and function. Let's blend both beauty and brains. Folks, I am totally convinced that if you articulate, advocate, educate, and investigate your data, you should be able to effectuate a solution. Ladies and gentlemen, nearly a decade ago, Dr. Masoka Fallah, and dedicated medical professionals who stood at the forefront of the Ebola outbreak in West Africa faced an unparalleled challenge. By harnessing actionable data, they exceeded monumental tasks that were before them. And their skillful use of information and technology not only saved countless lives, but also prevented what could have spiraled down into an Ebola pandemic. You and I both know what a pandemic is like, don't we? Yeah. Dr. Fallah's story, an emblem of courage and resilience, serves as a testament to the incredible achievements made possible when we balance art and science, combine form and function, and leverage beauty and brains. But you know what? They could not have done it at all without actionable data. Y'all remember the 3 tenets of actionable data? We've been talking about it all day. Data is actionable only when it helps us to do what 3 things? Make a decision, answer a question, or solve a problem. Very good. Excellent. So, remember, as we navigate the era of data-driven decision making, that actual data is not only the key to success, hey, it's the key to transformation. It's a guiding light that knows no boundaries. You now have the tools. Again, I say, let's go balance art and science. Let's combine form and function. Let's leverage beauty and brains. I leave you with this final challenge. Turn your ideas into reality by making data actionable and leverage brains and beauty to get it done. Thank you so much for your time.